Welcome back to College Algebra. For this refresher video, we're looking at solving rational equations. I've started by giving you a little bit of a reminder of how to find the lowest common denominator for rational expressions, and we're going to use that to solve rational equations. Let's take a look. Okay. When we think about solving rational equations, the first thing you really want to focus on is ensuring that all of your denominators are factored. That's hugely important. So you want to factor all your denominators first and then find those restricted values. We need to make sure that when we solve these equations, we don't fall into the trap of finding a solution that's actually extraneous, which means it doesn't actually make the equation valid at all. It's not a real solution. So essentially, it's almost like a hole, right? So if we had actually shown that our, for instance, restricted value is x equals 2, but then we go through the motions of solving the equation and we get x equals 2, we'd have to throw that solution away, and then we'd have to say, oh, I guess there is no solution. So we need to be very, very careful. We do not want to have a result that leads to a 0 in a denominator, because we know that that means that it would be undefined, right? That the equation would be undefined, so that is not a valid solution. Let's take a look. Okay, so we are going to use a technique of solving rational equations by canceling out fractions, which means we really do have to think about the LCD quite a bit. First things first, with problem number 1, I'm going to show what my restricted values are. So I noticed that I only have one denominator, and that's x. So we have to essentially say, well, let's set that equal to 0, right? So my restricted value would be that x cannot be equal to 0. Because if x were 0, this becomes an undefined fraction, which means my equation is undefined. Okay, so let's go through the motions and see what happens. First things first, I have 1, 2, 3 terms. So I'm going to multiply every term by the LCD. I only have an x in my denominator, so by default, that is my LCD. Every term gets multiplied by x. So x times x is simply x squared minus, notice here, numerator, denominator, so those divide out, and that leaves me with just a 5. And that's equal to 4 times x, which is 4x. At this point, we're going to set this equal to 0, so we're rewriting our equation in standard form. We have x squared minus 4x minus 5 is equal to 0. Do we have factors of -5 that combine to give us a -4? Well, 1 and 5, right? Where the negative would be attached to the 5. So we can actually factor this. The video before this one showed us the techniques for solving quadratic equations. So if you didn't watch that, but you're doing this first, and you're kind of like, oh, I forgot about that, go back to that other video. Okay, let's check it out. So we're going to go ahead and factor. We're going to use trial and error since my leading coefficients are 1. I'm going to break x squared into x, and then factors of -5 that give me a -4. That's going to be -5 times a +1, right? That should make sense. -5 times 1 is -5, and then -5x plus 1x is a -4x. Cool. Now that I have this completely factored and set equal to 0, I can now set each factor containing a variable equal to 0, and we solve. When I do so, I add 5 to both sides, so I find that x is equal to 5. I subtract 1 on both sides. I find that x is equal to -1. And now I can show that my solution set is -1 and +5. Those are my answers. The cool thing about this, we knew our restricted value was that x can't be 0, but we didn't break any rules, and neither of these are restricted. So -1 and 5 are both valid solutions. And that's it. We're done. For problem number 2, notice your denominators are already factored. There's literally nothing else we could do about this. So what we're going to do is we're going to start by identifying our restricted values. To figure that out, what we're going to do is essentially set each of these equal to 0. Now, if we set each of these equal to 0, do you all agree that if x plus 1 equals 0, then we subtract the 1 so that x cannot be negative 1. If you plugged in a negative 1 here, negative 1 plus 1 is 0. Okay, undefined. Cool. Similarly, if I set x minus 1 equal to 0, I have to add the 1, don't I? So that means x cannot be positive 1 either. So those are my two restricted values. Test it. 1 minus 1, 0. Okay, undefined. Now we're ready to proceed. We are going to take each of these three terms, package them in parentheses, and now I'm going to multiply by the LCD. So what you do to figure out the LCD is you essentially say, well, what are my factors? And you see here, this is an x plus 1, and this one's an x minus 1, and then this 4 is over a 1. So the LCD is just the combination of the two. It's like saying, if I wanted this fraction to have the same denominator as this one, well, that means I have to introduce an x minus 1 factor here. And then if I wanted this fraction to have the same denominator as my first, well, I have to introduce the factor x plus 1. And remember, what you do to the denominator, you would do to the numerator. Luckily for us, we're not just adding or subtracting fractions, we're solving an equation with fractions. We're solving a rational equation. So I'm going to take that LCD, which is x plus 1 times x minus 1, and I'm going to multiply every single term by that LCD. You will want to make sure you are super careful. Keep things highly organized. If this is not enough room on the page, please, by all means, do it in your notebook or on a separate sheet of paper, because you may need more room. Let's see how it goes. With our first fraction, notice our factors x plus 1 will divide out. So x plus 1 divides out with x plus 1. That's going to leave me with x minus 1 times 3x minus 2 equals. Now, for my second term, I have nothing to cancel, so I'm just going to write 4 times x plus 1 times x minus 1. There's a minus here, so be very careful with that. Minus. Now notice in our last term, the factors x minus 1 will cancel, and that leaves me with x plus 2 times x plus 1. Oh no, I hope my ink's not going away. That's okay. I'll find another pen. Next, let's distribute. So everywhere you see, we are going to distribute, and then we're going to combine like terms and see what happens, right? You took that first step to cancel fractions. That's beautiful, but now you got to do the math. Okay, now you have to actually distribute and see what happens. So if I go ahead and distribute, we get 3x squared minus 2x minus 3x plus 2 is equal to. Now, notice you have 4 times a product. I'm going to keep the 4 on the outside, and I'm just going to actually multiply these two together. Multiplying these two together gives us x squared minus 1x plus 1x minus 1. Okay. Next, notice I have a negative in front of this expression, so I'm going to keep the negative here, but I still need parentheses. We need to maintain parentheses until we distribute that negative throughout. So I'm going to multiply these two, but I'm going to keep that negative in front. X squared plus x plus 2x plus 2. Cool, not bad. Let's clean up. For the left-hand side, I have 3x squared minus 5x plus 2. Those two are alike. Now, inside the parentheses here, do you notice this negative x plus x are going to cancel each other out? So I'm actually just going to wipe those two out. And now I'm going to distribute the 4, if that's okay with everyone, instead of rewriting it. So we have 4 times x squared, which is 4x squared, and then 4 times a negative 1, which is negative 4. Now we have minus, and actually, if you want, please don't hate me. I'm about to kind of simplify here so that way I can, save some of this space. I'm just going to rewrite this as x squared, I'm squeezing it in, plus 3x plus 2. And now I'm going to distribute the negative to each of those terms. So that way we have negative x squared, negative 3x, negative 2. I hope you're all okay with that. I just wanted to save some room. Let's simplify this right-hand side after we rewrite the left. 3x squared minus 5x plus 2 is equal to 4x squared, take away x squared. These are like terms. That's a 3x squared. Then I have a negative 3x. And then a negative 4 and a negative 2 will give me a negative 6. This is looking pretty great. And now I actually noticed something very cool that's about to happen. Notice there's a 3x squared on either side. Well, if I go ahead and I subtract 3x squared from both sides, those are gone. So now I'm left with, those are gone, those are gone. Now I'm left with negative 5x plus 2. Notice I'm still moving from left to right, no matter what. Negative 5x plus 2 equals negative 3x minus 6. Now, after all of that, I have a linear equation, which should be cake to solve. I'm going to go ahead and add 5x. That gets rid of the 5x from the left, brings it to the right. So then at the same time, I'm going to go ahead and add 6. Bring that from the right to the left. Now I have 8 is equal to negative 3x plus 5x is 2x. And then I'm going to divide by 2. And x is equal to 4. With all of that being done, our final answer is that x is equal to 4. Notice it's not one of our restricted values. So da-da-da, we're done. All that beautiful work led to that one solution. Very, very nice. Let's go ahead and turn the page. For number 3, I've actually given you a gift, and I've gone ahead and I've factored this denominator for you so that you wouldn't have to spend the time factoring, okay? So it's all done for you. So the first thing we're going to do is we need to figure out what those restricted values are. So we're going to do that by taking the factors from the denominator and setting them equal to 0. Well, I have an x minus 1. And if we set x minus 1 equals 0 and we solve, we see that x cannot be equal to 1. That's my first restricted value because we have to add 1. My next factor is a 2x plus 3. So let's take that 2x plus 3, set it equal to 0. That means I have to subtract the 3, then divide by 2. So x cannot be negative 3 over 2. So we're going to keep that in mind. Those are our 2 restricted values. You guessed it, we're going through the exact same process of multiplying every term by the LCD. Notice, I have an x minus 1 here. To match these, I need a 2x plus 3, don't I? And then I have a 2x plus 3 in my last factor, or excuse me, my last term. So I would need the x minus 1 factor. What that tells me is that very clearly, my LCD is going to be the combination of the 2. So let's check this out. Place each term in parentheses. And now let's multiply by the common denominator, which is this big old thing here, this expression. The 2x plus 3 times x minus 1. And again, 2x plus 3 times x minus 1. And then again, 2x plus 3 times x minus 1. With our first term, the x minus 1 factors cancel. So that leaves me with 2x plus 3 times 4. So I'm just going to rewrite that with the 4 in front, of course. For my second term, ooh, this is cool. 2x plus 3's cancel. X minus 1's cancel. And that leaves me with 20. That's it, all by itself. Then we have minus 3, but notice that 2x plus 3's cancel, so it's going to be minus 3 times x minus 1. So negative 3 times x minus 1. That is fantastic. Notice we don't have any powers of 2, and when we distribute, we won't have a quadratic equation. This is simply linear, which is going to be really, really nice. Let's go ahead and distribute. That gives us 8x plus 12 is equal to 20. Be careful, distribute the negative with the 3. So that becomes negative 3x plus 3. Cool. I want to combine like terms. I always like to clean up terms on the same side if possible before moving from left to right. So this gives me 8x plus 12 is equal to, let's go negative 3x plus 23. Negative 3x plus 23. Okay, I'm going to bring the 3x over, and then I'm going to bring the 12 over. So let's add the 3x. Let's subtract the 12. Okay, and let's take a look at what we have. 8x, 3x, that's 11x. Cancel out those 12s. Bring down the equals. Cancel out those 3x's. 23 take away 12 is going to be 11. Divide both sides by 11, and we get that x is equal to 1. Uh-oh, that's our restricted value. So because we solved and we found the exact same value as our restricted, we actually cancel that out and we say, we can call this an extraneous solution. And then because this is an extraneous solution, I would say the answer is no solution or does not exist. Okay, another way you could write this in the software is x is equal to the empty set. There are no values within that set because there's no solution. Cool. Ooh, number 4 is our last problem of this section, and it is a little bit of a challenging problem, although I think you're totally more than capable of doing this. You just got to be really careful with that negative sign. That is a place that could really trip you up. So slow down, make sure you're keeping track of everything, and then move through the problem. You have the skills. Just slow down, move through the problem, keep track of those little details. Let's take a look. Okay, restricted values. And let's look at these. We have a 3x plus 1. So let's set that equal to 0. I know I'm writing not equal to 0 because it's a restricted value. So I have to subtract 1, don't I? And then divide by 3. So x cannot be negative 1/3. Cool. We also have an x minus 5. So if x minus 5 is not equal to 0, we solve, we show that x cannot be positive 5. So those are my restrictions. All right, whew, let's get after it. 1, 2, 3. Our LCD has to be this piece right here, 3x plus 1 times x minus 5. You already have an x minus 5, you need a 3x plus 1. You already have a 3x plus 1, you need an x minus 5, so it's got to be the combination of the two. So let's multiply every term by that LCD. So 3x plus 1 times x minus 5. I'm trying to squeeze this in. I don't want to lose anything and make this harder to see than it is. Okay, perfect. With my first fraction, the factors 3x plus 1s cancel out. And that leaves me with x minus 5 times 2x. So I'm going to bring that 2x in front. Cool. Equals. For our second term, x minus 5's cancel. And that leaves me with 1 times 3x plus 1. I'm rewriting it, even though I know it's just going to be the same. But I like to do it. For our last term, the 3x plus 1's cancel, and so do the x minus 5. So that leaves me with minus 4 times x minus 1. Let's distribute to drop parentheses. 2x squared minus 10x is equal to 3x plus 1. Don't forget to distribute the negative with the 4. Minus 4x plus 4. Let's clean this side up. 2x squared minus 10x is equal to, we have a 3x, take away 4x, so that's a negative 1x. We don't need the 1 there, but I'm going to write it anyways. 1 and 4 make 5. Now, we have a quadratic equation. which means this must be rewritten in standard form, aka we have to set it equal to 0. So these terms, which are definitely smaller in degree than my 2x squared term, they want to move over to the left. They want to join this largest term. So let's add the x, and we're going to subtract the 5. I'm just squeezing it in there. Okay, so I have 2x squared minus 9x minus 5 is equal to 0. At this point, we could attempt to use AC grouping on this because I have a trinomial. My leading coefficient is bigger than 1. And then what I'm doing in my mind is I'm saying, well, A times C is a negative 10. And do I have factors of negative 10 that give me negative 9? And my answer is yes, right? We can prove that. So I don't mind writing out here the technique we're using, which is AC grouping. So 2 times negative 5 is negative 10. Factors that give me a negative 9 have to be 1 times negative 10. 1 times a negative 10 is a negative 10. 1 minus 10 is negative 9. So that works. These are my two factors. Okay, we're going to drop this middle term and replace it with these two. So we have 2x squared plus x minus 10x minus 5 equals 0. This part right here with the factoring using AC grouping, that comes from our previous video called Factoring Fun or Factoring Galore, Factoring Techniques. Check that video out if you're still unsure about those factoring techniques, especially like AC grouping for trinomials whose leading coefficient is bigger than 1. We need that technique. So if you're still a little shaky, definitely check that video out. But let's keep going. Now that I have 4 terms, I can go ahead and group. That's the point. So you want to look at the first 2 terms and the second 2 terms. From my first 2 terms, my greatest common factor is x. That's the only thing I can factor out. That leaves me with 2x plus 1. Out of my second 2 terms, my GCF, notice I have a leading negative here. So my GCF is a negative 5. If I factor out that negative 5, dividing it out of each term, that's going to leave me with 2x plus 1, which is fantastic because these needed to be the same, and they are. Factor out that 2x plus 1 from both terms, and that's going to leave us with x minus 5. Let's go ahead and solve. Set each factor containing a variable equal to 0 and solve. To solve 2x plus 1 equals 0, we subtract 1, then divide by 2. So we get that x is equal to negative 1/2. For my second equation, I add 5. X is equal to 5. Look at the restricted values. I have a match, so that means I'm going to throw this one away. That is my extraneous solution. But the other one is valid, so I do have an answer. And we could say that for this problem, my solution set is negative 1/2. And we are done. Go ahead and try the solving rational equations in your practice block in your homework manager. Give that a shot, see how it goes. That's going to prepare you for what's coming up in college algebra. Okay, thanks for watching.